And I believe you can remember the skills needed in solving ordinary algebraic equations. I think it is time for you to learn how to apply them. Now, let us learn together how to apply all these skills that we've been told, one after the other, as we use them to solve some selected equations, especially our foregoing equations, which I believe you remember. In using each of these skills, just recall that every skill is used to clear an obstacle, preventing the unknown or the variable from having its full address, as learned earlier. In using each skill, there are steps that are recommended to follow. First, identify the obstacle you want to clear. Second, determine the skill that you are going to use to clear the obstacle. Three, apply that skill. The fourth one is that after applying the skill, you simplify both sides of the equation where possible and when possible. Meaning, because every equation of this sort contains left-hand side and right-hand side, after applying a skill to left-hand side and right-hand side, simplify each side if it is possible. Sometimes after applying a skill, both sides are simplifiable. Sometimes after applying a skill, only one side of the equation is simplifiable. In such cases, simplify only when it is possible and where it is possible, and leave the side which is not simplifiable. Take it forward to the next level and then keep treating the equation. Don't forget, in doing all of this, in applying all the skills, whether one skill or more than one skill, don't forget the principle of solving equations. What is it? Anything that you do to the left-hand side that changes its value must be done to the left right-hand side also. That is the principle of solving equation. Others say, whatever happens to the left-hand side happens to the right-hand side, but don't do it if what you are doing to left-hand side does not change the value of left-hand side. Now, let's see some examples. In applying the principle of solving an algebraic equation, which states that any new operation that takes place in left-hand side must be repeated on the right-hand side and vice versa. Please don't insist on applying every new skill on both sides. It is only when the skill you are applying to left-hand side changes the value of left-hand side that you apply it also on the right-hand side and vice versa. What then are operations or skills of solving equations that do not change the value of a side of an equation? The following operations do not change the value of a side of an equation. Therefore, don't insist on repeating these operations while solving equations. What are they? 1. Bracketing, that is putting numbers in bracket. 2. Opening brackets, that is when you want to expand brackets or just clear a single bracket. It is not compulsory you do to both sides. Number 3, factorization. Don't insist that if factorize left-hand side, the same thing should be done to right-hand side. Don't insist that if factorize left-hand side, that the same thing should be done to right-hand side. It does not change the value. The factorized is not to change the value of any side of the equation, so don't repeat it on both sides. The next one is collecting like terms. That you collect like terms on left-hand side does not necessarily mean that the same thing should be done to right-hand side. It might apply, but not compulsory. The last one I want to mention is change in number form. sometimes a number will change from ordinary form to index to make it easier to solve an equation. Don't insist that if a number turns from ordinary to index or index to ordinary, for instance, that the same thing must be done to the other side of the equation. Now, let's see how to apply the principle of solving equations in solving selected equations, especially our foregoing equations. Let's continue. Now, let's consider an equation in which the only obstacle is that the adder is not 0. It says x plus 5 is equal to 7. Watch out. Find the applications of skills of solving equations on the board. At this point, we are going to start with the first example that will help us see how to apply one of those 12 skills we just listed. Here, we seek to apply the first skill, which is making an adder become 0. Let us see. By means of solving selected equations, we learn these skills one after the other. Please, again, watch the board to find number A of examples which we intend to use to learn how to apply these skills. The equation says x plus 5 is equal to 7. It means that there exists an unknown number, and since it is unknown, we use the x to represent it. We don't know what it is, but when 5 is added to it, the answer is equal to 7. That is, something plus 5 is equal to 7. What is that something? I'm sure that with this statement, you will quickly rush into the answer and say the answer is equal to 2. Why were you able to get that 2 as the answer? Surely, even if you look at my own answer, you will find that the answer is equal to 2. But do not be deceived into using that same skill, that same process that you followed to get to in solving all kinds of equations. This is easy enough because the statement is clear. Something is added to 5 and the result is equal to 7. Everybody will know. Everybody that has basic knowledge of numbers will know that the answer is equal to 2. Don't trust that method you applied. The reason is that as equations become more and more complex, you may not be able to guess intelligently as we just did, because I'm sure that it is by guessing that you got these 2. Follow me as I use mathematical logic, skills, and principles of solving equations. That is the fundamental law of solving equations to solve this particular equation. The only obstacle we see in this equation is that there is a non-zero adder in the left-hand side. This x is the unknown, and this x does not possess all those qualities it is supposed to possess. It has all qualities, but 1 is not possessed. What is it? Instead of having 0 as its adder, it has 5 as its adder. Therefore, we call it a non-zero adder. I just call this 5 non-zero adder, meaning that 5 should turn to 0. The next thing is going to be, since 5 should become 0, what must be done to make that 5 become 0? It is not just because 5 is there. Any other number could be there. It could be 3, it could be 4, it could be anything. But in this case, it is 5 we are seeing there. As long as what is there is not 0, this skill we're about to apply here applies to all. Now, what must we do to make this 5 here become 0? Of all the ways that could make a number become 0, one is the most effective. And what is that? It is adding to it its additive inverse. Additive inverse is a number which when added to a number produces 0 as the answer. Experiment shows that the additive inverse of a number is that same number in its opposite sign. For instance, this 5 here has plus as its sign. I want to assure you again or recall or make you recall that this plus is not a sign of addition. This plus belongs to 5. In the previous lessons, you learned that fact. We're not going to stay long talking about it. It's just a reminder. Now, this 5 has this plus. What it means is that its additive inverse is the same 5 but minus. I repeat that additive inverse of a number is equal to that same number but in opposite sign. So the inverse of plus 5 is minus 5 and the inverse of minus 5 is plus 5. What about the inverse of minus 2? Anyway, in the course of time, I'd like to test out whether you really understood what I mean by this additive inverse. In the meantime, let's make progress. Line 2, since we have this plus 5 in the left-hand side, I want to convert that left-hand side to 0. Plus 5 minus 5. I'm having 5, I'm owing 5. So after accounting, it is 0. That is why this minus 5 was put here. That is the wisdom behind employing minus 5 to be added to plus 5. Now, does this minus 5 change the value of the left-hand side? Surely, the left-hand side had been x plus 5, but if I say x plus 5 minus 5, it becomes x plus 0. That means that by doing this, the left-hand side has changed to x plus 0. Therefore, adding minus 5 to left-hand side changed its value. This makes it compulsory that we have to go to right-hand side and apply the same thing. That is, go to right-hand side and also add the same minus 5. This is where at right-hand side we have 7 minus 5. Therefore, the next line says that x plus 0 is equal to 2. How was it gotten? It was got because plus 5 minus 5 is 0. That is to say, both sides were simplified. Both sides simplified. It means anytime you apply a skill, anytime you apply value changing skill to both sides of an equation, what you should do is to simplify both sides. That is, simplify the left-hand side and simplify the right-hand side where possible. Is it possible to simplify both sides in this case? The answer is yes. This x plus 5 minus 5 is simplifiable. It has brought us to x plus 0. And this 7 minus 5 is also simplifiable. It has brought us to 2. Therefore, when both sides are simplified, we now have a simplified equation that states x plus 0 is equal to 2. I hope you are following what is happening here. We just added additive inverse to plus 5, and this is what we have at the end of the whole thing. Now, can we simplify the left-hand side further? Yes. How? We recall that whenever 0 is added to a number, the result is equal to 0. Please get back to the basics of algebra, and which we learned earlier, so that with the lessons we learned therein, you can come back here and see why this x plus 0 is equal to x, and 2 remains 2. So at the end, the x is equal to 2. That x we did not know has become 2. I did not get my own by guessing. I got my own answer by following the principles and the laws and the philosophy of mathematics. At this point in time, just know that this x is equal to 2 is solution expressed. Solution to this equation expressed.